We're going to take a look here at some notes on polynomials, especially some vocabulary that you may or may not have seen before. So first, just what is a polynomial? So a polynomial is pretty much a lot of the functions we've already looked at. There are some that you notice are not in this list. I don't see a square root function in this list. Absolute value I don't see in this list. So to make a polynomial function, the function has to have real coefficients. So you just learned about complex numbers. You can't have any complex numbers inside your polynomial, like the square root of -1 or the square root of a negative number. And you have to have a whole number in the exponent. So if you notice, this is a constant function, so the exponent would have been 0, exponent of 1, exponent of 2, exponent of 3. So a whole number is just 0, 1, 2, and 3. There's no 4, 5, 6. There's no negatives, and there's no fractions. And polynomial functions are smooth and continuous. So smooth curves, absolute value comes to that like sharp point. So that's not a smooth curve. We're going to look at the degree of the polynomial, the highest exponent, and the leading coefficient is what's in front of the highest exponent term. So here are just some names of functions that I want you to be familiar with. Constant, linear, quadratic, I think those are pretty familiar. Cubic, quartic is 4th degree, and nth degree. So if it's x to the 5th, we call that 5th degree. X to the 6th, we call it 6th degree. So I want you to notice for polynomials, you just look at that leading term. Is it a 2nd degree, 3rd degree, 4th degree? So we don't add in any of the other powers. It's just a standalone. So a polynomial can be named by how many terms it has and its degree. So I think you know the terms monomial, binomial, and trinomial, meaning 1, 2, and 3 terms. So this would be a linear function, and it's a monomial, where this one is a linear function, but it has 2 terms, so we call it a binomial. And this is a quadratic, and it has 3 terms, so we could call it a quadratic trinomial. If I got rid of this last term, it could be a quadratic binomial. If I got rid of these 2 terms, it would be just a quadratic monomial, 1 term. I put this little note at the bottom here, kind of for PSAT or SAT questions. I'm not going to be talking about these type of expressions, but I see something that says 4y cubed, so that has a degree of 3. But y cubed is not a function, so we're not looking at that as a polynomial. So I wouldn't be assessing you on this piece, but if you ever see an x, y cubed term, that has a 4th degree. They're adding the degree on all of the variables together. Same thing over here. They're adding all of the degrees together. That's different than up here. For polynomials, you don't add together, the different terms. It's just that first leading coefficient. When you start throwing in other variables and x's and y's, there's another rule that you could add them together to get the total degree. So that's kind of a nice to know, but not to be confused with our polynomial unit. So I just wanted you to take a minute, pause the video, read through these 4 functions, and decide if it's a polynomial or not. Then write it in standard form and state the degree and leading coefficient. So I'll give you a hint. There's only one of these functions that fails as a polynomial function. So take a minute, pause the video, come to your conclusion. So decide which of these 4 functions you think fails. There's only one that fails. So in 5 more seconds, I'm going to say the answer. So I hope you paused until you come up with your conclusion. All right, so number 4 fails. It has a fractional exponent. So that is not a polynomial, but the other 3 actually are. So this is a polynomial, even though it has the number pi. Pi is a real number, right? It's not imaginary. It's just irrational. It's 3.14. It continued, 159. So this is also a polynomial. It's just not in standard form yet. And this is also a polynomial. 1/2 can be a coefficient. It just can't be an exponent. So I'm going to just pause the video, write the answers down. So you want to make sure that you're trying these on your own. Write them in standard form and state the degree and leading coefficient. I'm going to pause the video, so you should too. So if you just take a minute and look over your answers, make sure that you've ordered them in standard form each time, and you've stated the correct degree, and you've stated the correct leading coefficient. So we're zeroing in on that first term in each problem. All right, so now the term zeros refer to x-intercepts of the problem, and they're whatever x values make the polynomial zero. And if a polynomial can be factored, the zeros are the x values that make one or more of the factors equal to zero. A polynomial can have at maximum the same number of zeros as its degree. So a quadratic could have two x-intercepts, but it could have fewer. So remember, a quadratic, it could have two x-intercepts, might only have one x-intercept if it just touches the x-axis, might be up here and have no x-intercepts. So there could be as many as two. So it says it's the maximum of two if it's a quadratic, but it could have less. So if you have a cubic function might have only one x-intercept, but I'm running out of room. It could also have three x-intercepts. 3 being the maximum, might only have one. So I wanted you to practice factoring, finding the zeros, and sketching the graph. So we know that this is a trinomial. It's going to factor into what? X, let's see, 6 times 2. So x plus 6, x minus 2 are my factors. So the zeros are at -6 and +2. And we know that this is going to be a concave up. I could solve for the vertex, but it just says find the zeros and sketch the graph. So it goes through -6, +2. I know it has an intercept at -12, so it looks something like that. So just using the zeros to sketch the graph instead of laboring over finding the vertex like we've done. So this is another term that I want you to be familiar with, multiplicity. So it is the number, it's the multiplicity of a zero is the degree of the factor in which it appears. So x plus 6 has a power of 1. I don't see any squared or cubed there. So -6 has a multiplicity of 0. Multiplicity of, of 1. And 1 is odd. So we call that odd multiplicity. Same thing with 2. Multiplicity of 1, and that's odd. I'm going to tell you the difference between even and odd multiplicity. So what about this function? It's in factored form. I can see that 0 would solve the problem here. So 0 has a multiplicity of 1, but the x-intercept of 5, because this says 5 minus 5 squared, right? 5 actually has a multiplicity of 2 this time because of the 2 that appears in the power right there. So sketch this graph using a graphing calculator. So I just want to show you what this graph looks like. So you can go to your y equals menu. Hopefully you've got your calculator up on your screen. You're going to do x times parentheses x minus 5 squared. I'm going to hit zoom 6. All right, so my graph comes up really tall, bends down, touches the axis, and then shoots back up again. So it goes really steep, touches down, and then goes back up again. So it cuts through the axis at 0, and it bounces off the axis at 5. Whenever there's an even multiplicity, you're going to see that bounce off. Whenever there's an odd multiplicity, you're going to see a cut through. So that's stated on this page. Odd multiplicity, I think of that kind of like a linear graph, just goes through like a line. Even multiplicity, I think of like x squared. It kind of bounces off like a parabola. So I wanted to show you these two examples and look at the graph. So let's see, our zeros would be 0 and 1. So their multiplicity is 2, which is even, and 1, which is odd, right? Because there's a first power right there. So this is a multiplicity. Another reason they call this a multiplicity of 2, I could actually write this function out as x times x times x minus 1. How many times is that factor showing up? It's repeating twice, right? Multiplicity of 2, multiplicity of 1. So I can actually predict the shape of this graph. I know that the total degree of this function is 3, because if I multiply things out, I'll get x cubed. I know that the end behavior will be that the right side goes up and the left side goes down. I'm going to show you why in a minute. I know that at 1, it's going to cut through, and I know that at 0, it's going to bounce off. So it's going to look something like this. Let's see how close I got on my calculator. X squared times x minus 1. So let's see. Oops, I lost my graph here. Oops, I got pretty close. Mine's a little bit stretched out, but if I actually zoomed in using my window to be a little closer, -5 to 5, -5 to 5. So you can see that it comes up, bounces off at 0, scoots down a little bit, and then cuts through the axis. I'm going to talk about end behavior on the back page in a minute. All right, so now my two zeros are -1 and +1. This has a multiplicity of 3, which is odd. This has a multiplicity of 2, which is even. And to kind of emphasize that, if I wrote this function out, x plus 1 cubed is x plus 1 times x plus 1 times x plus 1. X minus 1 squared is x minus 1, x minus 1. 1, 2, 3, multiplicity of 3. 1, 2, multiplicity of 2. This is a 5th degree polynomial, because if I multiply this all out, I'd get x to the 5th. Right end going up, left end going down, cutting through at -1, but bouncing off at 1. So let's see how close I came. X plus 1 cubed times x minus 1 squared. Comes up, cuts through, bounces off, and goes straight up. So there's a little bit of this hiccup in here that I wasn't able to predict, but I've got the general pattern. All right, so I would like you to come back and do as best you can 1 through 7 that you're going to take a picture of and upload to the assignment in Google Classroom. But I'm going to skip on to the next page, which is end behavior and turning points quickly. And I'm actually going to pause the video and do a second video, so this is not too huge.